Good morning. I am Dr. M. Fatima from Sagar Institute of Research and Technology. I am taking subject analog circuits EC 405. In this, I am taking operational amplifiers. Operational amplifiers are so called since it can perform many operations like addition, subtraction, multiplication, log, anti-log, and many more applications. The different applications of op-amp is it can be used in different hardware of electronic devices. Like it can be used in hardware of television, in hardware of computers, in hardware of mobile, and in hardware of different electronic devices. Operational amplifier is available in the form of integrated circuits. Integrated circuits are usually called ICs and also called as silicon chip, computer chip, or microchip. This diagram is showing different form of ICs. Now this diagram is showing the pin configuration. Like here different pins are available, and on this side also different pins are available. So this IC pins are connected to the different connecting lines as shown in this diagram. The pins of this IC are connected to different connecting lines, and on this different connecting lines, the current start flowing. This diagram is showing the internal structure of the internal structure of the ICs. Here different components are fabricated and connected to the pins. On these pins, the different connecting lines are connected, or bus can be connected, like here it is shown here. So in this integrated circuit, different buses are connected, and you can see here in this picture, the current is flowing from this bus to the integrated circuit, and from here, from this IC to the bus. These ICs can also be used in printed circuit board as shown here in this diagram. Yeah, this is the IC, this is also the IC. Green lines are showing the connecting lines. These connecting lines are connected to the different pins of the ICs on printed circuit board, that is PCB. And these moving lines are showing the flow of current. Now, come to the classification of the IC. ICs are available in SSI, MSI, LSI, VLSI, ULSI. SSI is a small scale integration. Here, less than 100 electronic components can be fabricated on a single chip. Next is MSI, medium scale integration. Here, from 100 to 3000 electronic components can be fabricated per chip. In LSI, large scale integration from 3000 to 10,000 to 100,000 electronic components can be fabricated per chip. In very large scale integration, or VLSI, from 100,000 to 10 lakh components can be fabricated per chip, and in ULSI, in ultra large scale integration, more than 1 million electronic components can be fabricated per chip. Now the operational amplifier, this operational amplifier is available in the form of IC. This diagram is showing the pin configuration of the 741 IC, operational amplifier IC. The operational amplifier IC, the most popular IC is 741 series. So this is showing the pin diagram of operational amplifier. Pin number 1, 2, 3, 4, 5, 6, 7, 8. Here pin number 1 and 5 are used for balance or offset null. Pin number 2 is input. Pin number 3 is also input. This pin number 2 is called inverting input. This pin number 3 is called non-inverting input. The negative terminal or negative power supply is connected to the pin number 4, denoted by V minus. Pin number 6, the output is taken from here. On pin number 7, the positive power supply is connected, denoted by V plus, and pin number 8 is not connected. This operational amplifier is symbolized like here, it is shown here. the triangle, this is the symbol of the operational amplifier. This negative positive is drawn here, and this negative terminal is called inverting input. This is the pin number 2. This positive terminal is called non-inverting input. This is pin number 3. On pin number 4, V minus is connected, and on pin number 7, V plus is connected, and from pin number 6, output is taken. So this is a symbol of the operational amplifier. So there are two inputs, inverting input and non-inverting input, and there is only one output which is taken from pin number 6, and supplies are connected on pin number 4 and pin number 7. These supplies are connected for the biasing of the operational amplifier. Now come to the ideal operational amplifier. What are the parameters for the ideal operational amplifier? So for the ideal first of all, I want to see what is ideal. The ideal means what we expect from the operational amplifier. What parameters we expect from the operational amplifier. The voltage gain, it should be negative for the ideal, but practically this is not possible. The voltage gain for 741 IC is 2 into 10 raised to 5. The input impedance, the requirement is it should be infinite, but this is not infinite practically. This is very high. This is 10 raised to 12 ohms for FATE input operational amplifiers. The output impedance requirement, the ideal value, it should be 0, but obviously this is not 0. The bandwidth requirement, ideally it should be infinite, but practically this is having a range from few hertz to few megahertz. Now the operational amplifier without feedback. Here there is no feedback. So this diagram is showing the op-amp without any feedback. Here two inputs are given, V negative and V positive, and only one output. So if I'm talking about this operational amplifier, the output of this op-amp will be equal to the gain multiplied by V plus minus V negative. This gain depends on the operational amplifier. If it is open loop, that is like here without any feedback, then this gain is 2 into 10 raised to 5 for the 741 IC. Thank you. In the next lecture, I will take the operational amplifier with feedback. Thank you and take care.